Hello everybody, we're continuing with Geometry 5.5, the Triangle Inequality Theorem. Learning objective for today is prove triangle relationships using the Triangle Inequality Theorem. We have a couple of exercises that we want to do today, so let's get to them. So we want to write a two-column proof given that GL equals LK. Prove that JH plus GH is greater than JK. Alright? Let's start. Now with a two-column proof, we know that we have to create a table with a statement on the left side and reason on the right side. And we always start with the given, which is GL equals LK, and this is given. Next, using the Triangle Inequality Theorem, we can write JH plus GH greater than, so on the big triangle right here, JH, okay, this JH plus GH are greater than the third side, which is GJ, okay? And the reason for that, Triangle Inequality Theorem. Alright? Next, GJ equals GL plus LJ. Okay, if we have a large segment that's divided into two smaller segments, GLJ, obviously the large segment, which is this, equals the sum of the smaller segments. Okay, and this is called segment addition postulate. I never heard of it before, but I mean it's easy to figure out. Okay, now JH plus GH is greater than, they're greater than GJ, and we already said that GJ equal GL plus LJ, so we can write here GL plus LJ, and we're using the substitution here. Okay, so we substituted this for this. Okay, next, we're given that GL equals LK, so we're going to replace this GL with LK, so we can say JH plus GH is greater than LK plus LJ. Again, substitution. Okay, let me just write this in a neater way. Okay. G. Now, if we look at the small triangle, LK plus Lj, so Lk and Lj, the sum of these two sides is greater than the third side, which is Jk. So Lk plus Lj greater than Jk. Alright? And the reason for that is the triangle inequality theorem. Alright? Now, so let's look at what we have here. We have JH plus GH greater than LK plus LJ, and LK plus LJ is greater than LJK. So if this is the first and this is the second, this is the second and this is the third, these two are the same. So if the first is greater than the second and the second is greater than the third, that means the first is greater than the third. So JH plus GH is greater than JK. And the reason for that is the transitive property. Excuse my handwriting. So at the end we were able to prove that JH plus GH is greater than JK, which is what we have right here. That concludes our first exercise. Please pause the video at any time to follow what I did. Alright, let's look at this example from the book. This is much easier one than the one we did before. Write a two-column proof given that xw is congruent to yw. Prove that yz plus zw is greater than xw. So let's start with the proof. Statement, reason. We always start with the given. So xw is congruent to yw. Okay, that's given. Now, if we look at this triangle, yz plus zw is greater than yw, right? Yz and zw greater than the third side. And this is, the reason for that is the triangle inequality theorem. Okay? Now, we know that yw equals xw, so let's replace the yw here with the xw. Substitution. Okay, and there we have it, and that's what exactly we need to prove, that yz plus zw is greater than xw. This is, very simple proof. Let's look at another exercise. Given that angle BCD, which is this one, is congruent to angle CDB, which is this one, we want to prove that AB plus AD is greater than BC. AB plus AD is greater than BC. Alright? We're going to use the two-column proof. Let's start with this. Alright, so let's start with statement reason. Again, we start with the given angle BCD congruent to angle CDE, and that's given. We know that if two angles in a triangle are equal, then the triangle is an isosceles triangle, which means that BC equals BD. Why? Isosceles, Triangle Theorem. Alright? Now, by looking at the Triangle Inequality Theorem, we can say that AB plus AD greater than the third side, which is BD. This is the Triangle Inequality Theorem. And we know that BD equals BC, so we can replace BD with BC. So now we have AB plus AD is greater than BC, and the reason for that is substitution. We substituted BD for BC. Alright? And that's what we need to have. We wanted to prove that AB plus AD is greater than BC, and that's what we were able to do. Alright, pause the video to go over this one more time. Alright, for our last exercise, we want to determine the possible values of x. We don't have much time, so x plus 5 plus 5x minus 7 greater than 2x plus 22. Okay, if we simplify that, that would give us x greater than 6, and then 5x minus 7 plus 2x plus 22 greater than x plus 5. Simplify that. That would give us x greater than minus 10 over 6. And for the last one, x plus 5 plus 2x plus 22 greater than 5x minus 7. That would give us x less than 17. Do the number line, minus 10 over 6, and then 6, and then 17, greater than this, less than 17. They all meet right here, so the possible values for x is between 17 and 6. Okay? Sorry, I went too fast because I cannot go over 15 minutes. But you can do this yourself. Okay? And that's it for today. Stay safe and see you in the next video. Please don't forget to subscribe and leave some comments. Alright, bye.